Hello, my name is Michelle and I'm with Interns for Good, and I'm going to be talking to you today about how to factor quadratic and cubic equations. In this lesson, students will learn how to factor quadratic and cubic equations using methods such as greatest common factor, difference of perfect squares, trinomial, tricky trinomial, grouping, and the sum and difference of perfect cubes. The target age group for this lesson is between 6th and 8th grade, and students will acquire the skills needed to know how to factor quadratic and cubic equations. Factoring is the process of finding the terms that multiply together to get an expression. We are first going to be looking at the greatest common factor, or GCF method. The GCF is the greatest number that is a factor of each term of an expression. When looking at the set of 6, 12, and 54, the GCF is the number 6. What is the GCF of 21, 56, and 70? If you said 7, you are correct. Now let's look at an example. 5x plus 15. The GCF of 5x and 15 is 5, so we divide that out to get a final answer of 5 and then in parentheses x plus 3. Here is another example in which the GCF between 12x squared and 21x is 3x. So the 3x is divided out to get a final answer, which is shown here. Now it's your turn. Pause the video and try these 3 questions out. When looking at the first question, the GCF between 10x squared and 50x is 10x. So 10x is divided out to get this answer. For the next question, the GCF between 4x cubed and 8 is the number 4, so the 4 is divided out to get 4 and then in parentheses x cubed plus 2. And lastly, for the third question, the GCF is 7x, so the 7x is divided out to get the answer shown here. Now let's discuss difference of perfect squares. The two terms being subtracted must both be perfect squares in order to use this method. Perfect squares include values such as 4, 9, 16, 25, 36, etc., and also values such as x squared, x to the 4th, x to the 6th, and so on and so forth. So now let's look at an example. X squared minus y squared. In order to factor this, you must square root both terms. So the square root of x squared is x, and the square root of y squared is y. Then you put x and y in 2 sets of parentheses, and in one set of parentheses you put subtraction, while in the other you put addition. Whenever you're factoring difference of perfect squares, there is always one set of parentheses with subtraction and another with addition. So here's another example, 9a to the 4th minus 25b squared. The square root of 9a to the 4th is 3a squared, and the square root of 25b squared is 5b. There's one set of parentheses with subtraction and another set of parentheses with addition. It's important to note that all parts of each term must be a perfect square in order to be factorable using this method. So for instance, in this example, 2 is not a perfect square. So although x to the 6th and y to the 8th are perfect squares, this is not factorable using difference of perfect squares. Now it's your turn. Pause the video and try out these 3 questions. In the first question, the square root of x to the 6th is x to the 3rd, and the square root of 4y squared is 2y. One set of parentheses has subtraction and the other has addition. For the second question, it is not factorable because x cubed is not a perfect square. And lastly, for the third question, the answer is shown here. And again, one set of parentheses has addition and the other set of parentheses has subtraction. Now let's discuss trinomial and tricky trinomial factoring. Trinomials are expressions with 3 terms. The trinomial method is used for expressions with a leading coefficient of 1, such as x squared plus 2x plus 3. The tricky trinomial method is used for expressions with a leading coefficient greater than 1, such as 5x squared minus 3x plus 12. So this is an example in which you would use the trinomial factoring method. The first thing you need to do is ask yourself, what multiplies to negative 6 and adds to positive 5? When you think about the factors of negative 6, you will see that negative 1 and positive 6 multiply to negative 6 and add to positive 5. Now looking at another example, ask yourself the same question. What multiplies to positive 12 and adds to positive 7? The answer to that question is 3 and 4. It's important to keep in mind that not every trinomial is factorable. Here is another trinomial, and it's always important to try and simplify a trinomial down if there are GCFs present amongst all three terms. In this situation, there is a GCF, and that GCF is the number 6. So 6 is divided out to get 6, and then in parentheses, x squared plus 2x minus 3. And now you can proceed using the trinomial method and ask yourself, what multiplies to negative 3 and adds to positive 2? And the answer is the numbers negative 1 and positive 3. Now here's an example in which you would have to use the tricky trinomial factoring method. The first thing that needs to be done is you have to multiply the a term, which in this situation the number 3 is known as the a term, by the c term, which in this case is the number negative 11. So 3 times negative 11 is negative 33. The next step is to put 3x at the beginning of both sets of parentheses, and then ask yourself, what multiplies to negative 33 and adds to positive 8? You will see that the answer to this question is positive 11 and negative 3. So then you need to find a GCF in either one of or both of the sets of parentheses and divide it out. In this situation, there's a GCF in the set of parentheses with 3x minus 3, and that GCF is the number 3. So the number 3 is divided out to get a final answer of 3x plus 11 in one set of parentheses and x minus 1 in another set of parentheses. If you are ever unsure if you did the process correctly, you can always double distribute and multiply it out to see if you get the original expression. Now it's your turn. Pause the video and try out these 3 questions. Looking at the first question, this is an example in which you would have to use the trinomial factoring method. So ask yourself, what multiplies to negative 10 and adds to negative 3? The numbers 2 and negative 5 fit this description, so the answer is shown here. The next example, there is a GCF that you can factor out in order to simplify the trinomial. The GCF is the number 3, so we divide it out to get 3 and then in parentheses x squared minus 4x minus 5. And now you can proceed using the normal trinomial factoring method to get this final answer. The third question is an example of a tricky trinomial expression. Multiply the a term, which in this situation is the number 4, by the c term, which is negative 9, to get negative 36. Then put 4x at the beginning of both sets of parentheses and ask yourself what multiplies to negative 36 and adds to positive 5. The numbers 9 and negative 4 multiply to negative 36 and add to positive 5. There's a GCF of 4 in the set of parentheses with 4x minus 4. So we divide that 4 out to get a final answer, which is shown here. Next, we're going to talk about grouping. The simplest situation that requires grouping is when you're dealing with a polynomial with 4 terms. To use grouping, the first 2 terms and the last 2 terms must have individual common factors. So when looking at this 4-term polynomial, the first thing that you need to do is to look for a GCF between 2x cubed and 4x squared, and a separate GCF between negative 5x and negative 10. There is a GCF of 2x squared between the first two terms and a GCF of -5 between the last two terms. So these two GCFs are divided out to get what is seen here. Notice that the values that are inside the parentheses are the same. This is extremely important whenever you're doing grouping. So combine the GCFs into their own set of parentheses and include only one set of parentheses with x plus 2 to get this as your final answer. Now it's your turn. Pause the video and try out these 3 questions. When looking at the first question, the first thing you want to do is look for a GCF between the first two terms and the last two terms. Between the 3x cubed and the -12x squared, there's a GCF of 3x squared. And when looking at the 4x minus 16, there's a GCF of 4. So these two GCFs are divided out to get what is seen here. Now we combine the GCFs into their own set of parentheses and include only one set of parentheses with x minus 4 to get this final answer. When looking at the second question, we do the same thing. We look for GCFs between the first two and the last two terms. In this situation, the two GCFs are 7x squared and positive 2. And then we combine the GCFs into their own set of parentheses and include only one set of parentheses with x minus 5. For the third question, we again look for a GCF between 6x cubed and 15x squared, and another GCF between 10x and 25. So the two GCFs are 3x squared and positive 5. These two GCFs will be put in a set of parentheses together, and we will keep one set of parentheses with 2x plus 5. Now let's discuss the sum and difference of perfect cubes. In order to use this type of factoring, both terms must be perfect cubes. Perfect cubes include values such as 8, 27, 64, etc., and x cubed, x to the 6th, x to the 9th, and so on and so forth. So first, we are going to discuss sum of perfect cubes. There is a general formula to keep in mind whenever you're doing this type of factoring. And that formula is shown here. It's a plus b in one set of parentheses, and then a squared minus ab plus b squared. And then when you're doing the difference of perfect cubes, there is a similar formula, but the signs of the operations are a little bit different. So you have a minus b in the first set of parentheses, and then a squared plus ab plus b squared. A good way to remember what operation is where is to think of the acronym SOAP, which stands for same, opposite, always positive. So say you're doing difference of perfect cubes. The first operation you're going to be doing is subtraction because that's the same as your original expression. Then the next operation will be the opposite, which is addition. And then the last operation is always addition, regardless of whether you're doing sum of perfect cubes or difference of perfect cubes. Now let's look at an example of the sum of perfect cubes. So plugging into that formula, we get y squared plus 2x, and then y to the 4th minus 2xy squared plus 4x squared. And then looking at difference of perfect cubes, we plug into the formula and get the answer seen here. It is important to keep in mind that all parts of each term must be a perfect cube in order to be factorable using this method. So in this example, which is 3x to the 9th minus 8y to the 4th, the number 3 is not a perfect cube, and y to the 4th is also not a perfect cube. Now it's your turn. Pause the video and try out these 3 questions. So looking at the first question, it is a sum of perfect cubes. So we plug in the values that correspond with the formula to get the answer seen here. For the next question, it is a difference of perfect cubes. And same idea, we plug in the values into the original formula to get this answer. And then the last question is not factorable because 9 is not a perfect cube. Here are some links if you want some additional practice. They are divided based on the method of factoring, and towards the bottom there's also a practice which incorporates multiple different types of factoring. And there's also a game at the bottom if you're interested in playing. My name is Michelle Serbin, and I love doing all sorts of activities such as playing piano and doing research, and I really hope this video helped you out.